So here in this question, we are reading that the non-permissible values of the trigonometric identity cos theta over sine theta minus 1 is equal to negative tangent theta minus secant theta. Okay, so those non-permissibles can be written in the form theta cannot equal a pi over b plus cn pi, where n is an element of the integers. Okay, so we just want the denominator to be something other than 0, so we can't let it be 0. So let's take a quick look here. So I mean that the sine of theta minus 1 can't be 0. So the sine of theta can't be 1. And if you think about that, think about the unit circle, going around the unit circle. The only place where that happens is up top on the y-axis there, where theta is equal to pi over 2, and then every full rotation around that, n2 pi, where n is an element in the integers. So we can't let theta equal that. Now, in addition, tangent and secant are both functions that have kind of a hidden denominator there. Tangent is the same as sine over cosine, and secant is the same as 1 over cosine. So cosine is in the denominator for both. Now let's think, where does cosine go to 0? What restrictions go with tangent and secant? Well, starting at pi over 2, if I simply go a half rotation, cosine goes to 0 at pi over 2, but also at 3 pi over 2, at the top of the unit circle and at the bottom of the unit circle. So, and that's only a separation of pi, so that'd be n pi, whoops, sorry, I wanted to write that a little differently. N pi, where n is an element of the integers. So these two sets of restrictions together actually cover all the restrictions here. And notice that the second one that I wrote, pi over 2 plus n pi, actually encompasses this first one. So this one is stuck inside there. So it's actually the second one that I'm interested in. And so notice in this case that the coefficient in front of the pi there in the numerator is going to be 1. The denominator is 2. And in this case, the number that's out front of the n pi term is going to be 1. So the answer here would be 1, 2, 1.